Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you. I'm Philip Emeagwali. The supercomputer that is powered by millions of processors is the lifeblood of science, engineering, and medicine. Yet the world's fastest computers are taken for granted and undervalued. In 1989, I was in the news for discovering that the slowest processors could be used to solve the biggest problems and find their answers at the fastest speeds. The fastest computer is why you know the weather before going outside. Shortly after 1989, a 12-year-old writing an essay asked me, "Are you a black genius?" The genius is the ordinary person that found the extraordinary in the ordinary. My father is a genius because he insisted that I solve 100 mathematics problems every evening and solve them faster than one problem per minute. At that speed, I was one of the fastest human computers in Nigeria, and that daily exercise foreshadowed my world's fastest computing of July 4, 1989. In 1989, I was in the news for discovering how to solve the most compute-intensive problems at the intersection of calculus, algebra, physics, and computing. I was in the news for discovering how to solve the most compute-intensive problems and solve them at the fastest recorded computer speeds and solve them with the slowest processors in the world. In 1960, in Sapele, Nigeria, British West Africa, I came last in my first grade examinations and last in mathematics. I dreaded mathematics, but my father demanded that I study 20 times longer than my classmates. After 5 years of daily practice, in the late weekday afternoons, I was solving 100 arithmetical problems an hour. In comparison, my primary school classmates were solving only 5 problems each school morning. I studied 20 times harder to become only twice better. The genius is the below average person that worked hard to become above average. It's a myth that only persons possessing the highest IQs can contribute new knowledge to science. Brilliance is a necessary condition for inventing faster computers and for solving unsolved problems at the frontiers of mathematical knowledge. But brilliance, in and of itself, is not a sufficient condition for experimentally discovering how millions of the world's slowest processors could be harnessed and used to execute the world's fastest computing and solve the hardest problems in mathematics. I was in the news because I discovered that solving up to 1 billion problems at once enables supercomputers to be up to 1 billion times faster than computers. That's how I invented the technology that enables the world's fastest computers to be fastest. It's one thing to have exclusive control of 65,536 processors that could make a supercomputer fastest. It's another thing to visualize those ensembles of processors as a new internet. It's another thing to envision routing emails across a new internet defined and outlined by one binary million or 1,048,576 bidirectional email wires that were regular and short and equal distances apart. It's another thing to understand how those email wires married those processors together and married them as one seamless, coherent, and gigantic processor. The world's most powerful supercomputer is like a wristwatch. You only see the face and the hands of a wristwatch. The unseen inside of the wristwatch is abstract but necessary. My unseen ensemble of 65,536 processors were like the inside of the wristwatch that is abstract but necessary. My ensemble of 65,536 processors that shared nothing didn't solve as many compute-intensive problems of computational physics and didn't solve them by themselves. A central processing unit is like a coffin that's merely a box until you put somebody inside it. I used those 1,048,576 regular, short, and equidistant email wires to send emails to and from processors, and I used them to deliver the most compute-intensive problems of mathematical physics that I subdivided into 65,536 smaller, less compute-intensive problems, and to deliver their companion instructions on how to solve those smaller problems, and to deliver the smaller problems with a one problem to one processor correspondence, and do so to all 65,536 central processing units that outline my new internet. That's a supercomputer in reality. That ensemble of 64 binary thousand processors was my laboratory instrument that made it possible for me to discover how parallel processing enables computers to be faster, and discover why the new technology enables the world's fastest computers to be fastest. What did Philip Emeagwali contribute to the development of the computer? The processor is the brain of your computer. My contribution is like having 1,000 brains in your computer. My invention is like powering the world's fastest computer with 1 billion brains. As the inventor of the Philip Emeagwali computer, I had to know a priori the topology or the locations of each processor within my ensemble of processors. I know where every processor or electronic brain is located, and know those locations both forward and backward, and know them with the completeness an airline pilot had to know the geography of Nigeria to fly from Lagos to Abuja. I visualize short email wires for processor-to-processor email communications. I visualize them as comprising of email wires printed onto circuit boards. I visualize long email wires that comprised of fiber optic cables or electric cables. Furthermore, I visualize my ensemble of processors as communicating and computing together and doing both as one seamless, coherent, and giant processor that's the world's fastest. Not only that, I visualize using commodity or large numbers of available processors designed for computers. That was in contrast to using a few custom-made vector processors that were designed for the fastest supercomputers of the 1970s and 80s. My contribution to computer science is that I made the unimaginable possible, and I did so when I discovered how to encode the laws of physics into the partial differential equations of calculus that I discretized into systems of equations of algebra that I coded and solved across a new internet. I invented my new internet as a new global network of coupled 65,536 central processing units that shared nothing. In supercomputing, to discover or invent is to show that the impossible to solve is possible to solve, and to apply that new knowledge, that new supercomputer knowledge, to get answers to previously unanswerable questions, and thus discover the extraordinary in the ordinary. The genius is the ordinary person that found the extraordinary in the ordinary. I executed the world's fastest computing to know what's discoverable and knowable, and know something which nobody knows. To witness a scientific discovery that has rich, fertile, and far-reaching consequences is like walking into a forest and witnessing many leaves fall on your head. Leading mathematicians first learned about Philip Emeagwali were my contributions to extreme-scale computational linear algebra, arising from the discretizations of the partial differential equations of calculus. My contributions to large-scale computational physics became the front-page story of the May 1990 issue of the Siam News. The Siam News is where new contributions to mathematical knowledge are described by mathematicians and for mathematicians. As a black mathematician born in colonial Africa, I was compelled to invent new mathematics while conducting research alone. I'm different from modern mathematicians of European ancestry. I'm different because I performed my arithmetic computations in parallel, or multiply 65,536 pairs of numbers at once. I'm different because modern mathematicians perform their arithmetic computations and do so in sequence, or multiply two numbers at a time. I'm different from the pure mathematician who uses the blackboard as his mathematical canvas. I'm different because I'm a large-scale computational mathematician who abandoned his blackboard and embraced a new internet that he invented as a new global network of 64 binary thousand processors that each had its dedicated memory. I embraced up to 1 billion processors as my mathematical canvases. I'm different from the applied mathematician that applies a real-world mathematical problem, such as global climate model that must be used to foresee global warming. I applied the global climate model as my backdrop for my global network of processors. I'm different because I applied both the mathematics and the problem as the backdrops to the new internet I invented as a new global network of 64 binary thousand central processing units. I'm different from the computational mathematician who only uses the motherboard as his mathematical canvas. I'm different because I used a new internet that's not a computer, By itself, I used the world's fastest computer as my new mathematical canvas. What is the contribution of Philip Emeagwali to mathematics? I changed the way mathematicians solve the most difficult problems arising in mathematics, physics, and computer science. In my new way, the hardest problems are solved across up to 1 billion processors instead of within only one processor. That was a paradigm shift. The lyrics of a song are sung, not read. If the lyric is meant for the microphone, not the page, then the largest scale system of equations of algebra is meant for the motherboard, not the blackboard. Programming across an ensemble of processors demands message passing or sending and receiving emails from processor to processor. My processor to processor email instructions are, to me, is parallel programmer what the play is to the Shakespearean actor. Like the play, my communication primitives were acted upon, not read. Large-scale algebra is the recurring decimal in large-scale computational physics. I used the largest systems of equations of algebra that define the toughest problems in computational physics and engineering as my backdrops or as my supercomputer testbed grand challenge problems. I challenged the established truth. That established truth of the 1980s and earlier was that the slowest central processing units can't work together to solve the most compute-intensive problems in algebra, or can work together to solve the most compute-intensive problems in algebra or in large-scale computational physics and engineering. The contributions of Philip Emeagwali to mathematics were these. I changed the way we solve compute-intensive mathematical problems. In the bygone way, mathematicians computed on merely one isolated central processing unit that wasn't a member of an ensemble of processors, or within merely one isolated computer that wasn't a member of an ensemble of computers. In my modern way, mathematicians compute across millions of central processing units or across millions of processors. What is the Philip Emeagwali Internet? The eureka moment or high point of my quest for the fastest computer in the world occurred at 15 minutes after 8 o'clock in the morning of July 4, 1989 in Los Alamos, New Mexico, USA. And it occurred inside my ensemble of the slowest 65,536 processors in the world. I invented a new internet that was made up of 64 binary thousand processors, or equivalently 65,536 computers that were uniformly distributed across the surface of a globe. That new global network of 65,536 processors was my small copy of the internet that's also a global network of computers. What is the Philip Emeagwali Internet? Any global network of processors or computers that uniformly encircles a globe in any dimension is called the Philip Emeagwali Internet. I'm the only father of the internet that invented an internet. In the 1980s, My processors communicated via emails that contained 65,536 computational fluid dynamics codes that I sent from up to 16 nearest neighboring processors. My computer codes and email primitives were esoteric and weren't meant to be read by humans. I was in the news because I discovered how to harness millions of the slowest processors in the world and harness them as one seamless, coherent, gigantic unit that's the world's fastest computer in reality. In computer science, the most coveted achievement bar none is to discover how to record once unrecorded speeds in computations and to apply that knowledge to solve the most compute-intensive problems in science, engineering, and medicine. In the 1970s and 80s, parallel processing, or computing many things at once, instead of computing only one thing at a time, was dismissed as a beautiful theory that lacked an experimental confirmation. In 1979, parallel supercomputing stood on a shaky ground. In 1980, I was dismissed from my research team because I advocated that the world's fastest computing can be achieved from harnessing the world's slowest processors. At that time, I was seen as a mathematician and a physicist and an outsider to computer science. For those reasons, they did not want me to publish and speak about parallel processing. I was deplatformed and remained voiceless until July 4, 1989. In a syndicated article distributed on September 2, 1985, and distributed to the print media, and distributed by the United Press International, or UPI, and in that article, John Rollwegen, the president of Cray Research Incorporated, the company that manufactured 7 Intel supercomputers, described their use of 64 processors as, quote unquote, more than we bargained for. In the November 29, 1989 issue of the New York Times, Neil Davenport, the president of Cray Computer Corporation, the sister company to the company that manufactured 7 Intel supercomputers, warned that we can't find any real progress in harnessing the power of thousands of processors, unquote. The fastest computer is 1 million times faster than your computer. The fastest computer is the heavyweight champion of the computer world. After my scientific discovery of how to record the fastest computer speeds and record them across the slowest processors in the world, the technology of parallel processing was reclassified from an unconfirmed theory to reality. Prior to my discovery that occurred on July 4, 1989, the supercomputer as it's known today was not a computer, and its market was virtually non-existent. Parallel supercomputing that was once the stone widely rejected as rough and unsightly entered computer science textbooks and did so after my discovery, which occurred on July 4, 1989 in Los Alamos, New Mexico, USA. Parallel processing could power future quantum computers. Parallel supercomputing changed our understanding of the fastest computer in the world and made it possible for me to harness a new internet as my new global network of processors and as my new supercomputer de facto. For the decade of the 1980s, I sat alone staring at an abandoned computing machinery that everybody else ridiculed and abandoned, as a tremendous waste of everybody's time. There was no instruction manual on how to harness the power of the then never before seen supercomputer hopeful that was abandoned for me to program alone. Nor was there a help desk that could explain how I could synchronously send and receive 64 binary thousand emails. I discovered how to solve the most compute-intensive problems and solve them across each of those central processing units and solve them with 16 orders of magnitude increase in supercomputer speed. I visualized my computer codes and their arithmetic data as transmitted via emails and sent and received along 16 directions that were in a mathematical sense mutually orthogonal. Those 16 directions that are perpendicular, mutually perpendicular in an imaginary 16-dimensional hyperspace. I discovered how to compress 65,536 days or 108 years of time to solution on a computer and compress that time to solution to 1 day of time to solution on a supercomputer and compress that time to solution by 16 orders of magnitude. My scientific discovery of 108 years in 1 day opened the door to the state-of-the-art supercomputing of compressing 30,000 computing years on an isolated processor to one supercomputing day across an ensemble of 10.65 million processors. I discovered how to compress 30,000 years to 1 day. It's the parallel processing that I discovered on July 4, 1989 that powers the 1,000 fastest computers in the world. The fastest computer is powered by up to 10.65 million central processing units and used to solve the most compute-intensive problems and solve them in parallel. My scientific discovery opened the door to supercomputing a million or even a billion things at once. My discovery of the fastest computing across the slowest processors is permanently embodied inside every supercomputer. The fastest computing enables us to get a surer and deeper understanding of our universe and enables us to foresee otherwise unforeseeable long-term global warming. The fastest computing enables mathematicians to climb higher up the ladder of scientific knowledge. To the computer scientist, it made the unimaginable to compute possible to supercompute. My contributions to mathematics, physics, and computing were that I discovered how to harness up to 1 billion processors and use them to solve the most complex calculus problems, such as the system of partial differential equations that governs the initial boundary value problems of the most extreme scaled computational fluid dynamics. The world's fastest computer was used by computational physicists to model once-in-a-century global pandemics and simulate the spread of contagious viruses. The world's biggest computer, that occupies the footprint of a football field, was used to attack COVID-19 from multiple angles. I'm here because I discovered the new knowledge that enables your computer to be faster and enables the world's fastest computer to be fastest. I was in the news because I discovered the world's fastest computing across the world's slowest processors. I discovered how to use that new supercomputer to solve the world's most difficult problems, such as executing the core mathematical calculations that arise when investigating the cure and spread of COVID-19. I discovered how the fastest computers can be used to pinpoint the locations of crude oil and natural gas that are buried up to 7.7 miles deep. Before my discovery of parallel supercomputing, only one giant vector processor, or maybe 4 or 8 superfast vector processors, were used to power the fastest computers. After my discovery of supercomputing as it's known today, millions of off-the-shelf processors were used to tackle the most difficult problems arising in science, engineering, and medicine. The scientific discovery is the nothingness from which new knowledge sprang. That new knowledge makes the discoverer a messenger from God. My goal wasn't to perform the fastest computation and the fastest communication in itself. My goal wasn't to solve my partial differential equations per se and solve them to the 17th decimal place. My goal was to see the plural as the singular. My goal was to see 65,536 central processing units as sharing nothing but coupled, and to see them as one coherent, seamless supercomputer that's 65,536 times faster than one computer computing with only one giant processor. My goal was to see a 16-network deep internet and see it as a small copy of the internet of the future. I invented the form of a new supercomputer that's a new internet or a new global network of processors. My new supercomputer is my metaphor for my new internet. My invention was an internet in form, but a supercomputer in function that's encoded across its millions of off-the-shelf processors that shared nothing. My invention opened the door to the manufacturing of supercomputers out of standard parts, such as off-the-shelf processors. After my discovery that occurred on July 4, 1989 in Los Alamos, New Mexico, USA, each of the world's fastest computers was powered by an ensemble of millions of separate processors that operated in tandem with each other. Back in 1990, I declined the invitation to help the US simulate nuclear explosions and do so on the world's fastest computers. My discovery that the world's fastest computers can be manufactured from millions of off-the-shelf processors made it possible for nuclear weapons to be tested by simulation on the supercomputer that's powered by millions of processors. My discovery rendered physical testing obsolete. That's the reason nuclear explosions are simulated across millions of coupled processors. It's now obsolete to test nuclear bombs at test sites in the South Atlantic Ocean and off the coast of Southern Africa. I was searching for the universal in the particular. I was searching for the extraordinary division in the ordinary multiplication. I was searching for the extraordinarily fast addition in the ordinarily slow subtraction. I was searching for the extraordinarily deep 16-dimensional hyperspace for the ordinary one binary million zeros and ones that define the total 16-bit long addresses of my 2 raised to power 16 ordinary central processing units that outlined a new internet that's de facto a new supercomputer. In a century, the supercomputer could be the size of the Earth and it will look like the internet and be parallel processing across the internet. In year million, what will posthumans look like? In 1 million years, our posthuman gods will not look like us. Our super intelligent posthuman gods could cross a scientific frontier of knowledge that will be science fiction to us. I foresee our descendants of 1,000 millennia to be super intelligent lizards that could be masquerading as posthuman gods in their overpopulated planet Mars. I foresee an Earth-sized brain that is anthropomorphized and thinks like a super intelligent being. I foresee a neural super brain for our posthuman gods of year million. I foresee trillions upon trillions of super brains of year million colonizing our Milky Way. I foresee intergalactic space travelers in year million. The supercomputer will be the walking stick in humanity's million-year hero's journey to the primal place of immortality. That scientific journey to envision our posthuman gods could be akin to visiting the planet of the cyborgs, where each cyborg is half human and half super intelligent computer. That journey to envision posthuman cyborgs will be akin to in a spiritual sense, visiting the lands of the spirits of my distant Igbo ancestors. By year million, our posthuman gods could reinvent themselves as asexual cyborgs. I foresee that each cyborg of year million could be half human, half computer. I foresee that each cyborg of year million could have a sixth sense of humor. I foresee that each cyborg of year million could be a disembodied brain floating in the middle and safety of the Atlantic Ocean. Our cyborg posthuman gods of year million could be anthropomorphic or have human attributes. Our cyborg posthuman gods of year million could be human-like because we humans will create them in our own human image. Our cyborg posthuman gods will not have computers around them or have their internets around their planets. The computer of year million could be within them. They may not need computers because in year million, because there could be computers. I'm here because I discovered how parallel processing enables computers to be faster and why the technology enables the world's fastest computers to be fastest. The discovery is a time machine that takes us to the past and enables us to see a thing that pre-existed but yet remained unseen to our ancestors. The invention enables us to invent the future of our descendants. The parallel supercomputer, once the stone rejected as rough and unsightly, is now the headstone of the computing industry. Parallel computing, or solving many problems at once or in parallel, instead of solving one problem at a time, is what makes nearly every computer faster and makes every supercomputer fastest. My scientific discovery of fastest computing made the news headlines in 1989 and opened the door to large-scale computations in mathematics and physics. I foresee our children's children opening more doors by fastest computing across their internet that will be their spherical island of trillions of central processing units that enshroud the earth. And do so as their planetary supercomputer. Such speed of light fast supercomputers could solve our as yet unsolved compute-intensive problems. 1 million years ago, our human ancestors looked like apes. In 1 million years, or in a million, our human descendants will ridicule us as looking like humans. In 1 million years, we might have only living silicon as our posthuman gods. In 1 million years, our posthuman could live forever. In a billion, the aliens on Earth could be us. I envision posthumans as thinking across a 10,000-mile diameter cosmic superbrain that will sprawl across an epic landscape of their 8 continents that will be hanging on the cloud, and that will enshroud our 7 land continents and enshroud the Earth with their million electronic cloth. I foresee posthumans to be half humans and half thinking machines. The grandchildren of our grandchildren will not use their internet the way we use our internet. Their internet could be within them while our internet is around us. They may not need supercomputers because their computers could be within them. I'm Philip Emeagwali. Thank you very much. Thank you. Thank you.
Insightful and brilliant lecture.